is a bit of a controversial title, right? Because I've discovered that that's what gets you into conferences, controversial titles. And it refers to an article that DHH, the Ruby on Rails guy, DHH, wrote a couple of years ago called TDD is Dead, about how TDD is a load of rubbish and we don't need it. But my argument is that it's not quite dead, it's just metamorphosed. You know, if you live in London, you hear a lot of old punks saying things like, punk's not dead, punk's not dead. Frank Zappa, the American musician, famously said, yeah, punk's not dead, it just smells funny. So this is me. I work for Invika, trainer and software engineer. We do a lot of e-commerce stuff, so testing is paramount, and we advocate a methodology called full stack BDD. I'm not going to talk about the whole full stack of it, just the lower end of it, called TDD, or spec BDD, depending on who you're talking to. And I thought that the word test is probably the best way to start a conference talk about testing, or what testing isn't about, because it's in the phrase test-driven development. And the word test probably conjures up a lot of images and ideas in developers' heads, right? Like medical tests, maybe, or not. So I assume most of you have done some sort of testing on your software. Who tests their software before it's released? Oh, not that many, okay. You know, like browser, refresh, change a few variables, reload again, give it to the QA, maybe they can test it. Who writes automated tests? Okay. And who writes unit tests before the code is written? You're weird. So, one of the main thrusts of the talk is that there's a misunderstanding about the word test, especially in the context of test-driven development. And, you know, these square brackets, they mean there's a dictionary definition coming up. Because in English, test can be a noun, and it can be a verb, and they mean slightly different things. So test the noun is a procedure intended to establish the quality, performance, or reliability of something, especially before it's taken into widespread use. Who does that? So that's the noun, and it's something you can do beforehand. But there's test the verb, which means something slightly different, to do something in order to discover if something is safe, works correctly, or if something is present. Clearly, that's the kind of test you can't do before the system exists, right? Someone says to you, I want you to build a very complex washing machine, but I'd like you to test it first. You go, what? Another bunch of synonyms for the verb test are to prove, to assess, to examine. These are all things that we cannot possibly do before the thing that we want to test exists. We can't prove that something works, or assess that it does the correct thing, or examine its output before it exists. So clearly, test the verb and test the noun are used interchangeably, and in the phrase test-driven development, this leads to a lot of misunderstandings. The old school way of doing things, and this is the way I used to do things several years ago, was to write code and test that it works. And I used to work for this very big company. We delivered to millions of people. And for every component, we were asked to write a bunch of unit tests just to show that the component we designed actually works correctly. And the TTL wouldn't check anything in until the tests pass. Whether they were correct tests or not wasn't very important as long as they passed. And you can miss a lot of edge cases that way, right? But this is the way we used to do it, and this is the way most people understand software testing. You write some kind of function. You're supposed to do the sum of two numbers, and then you make an assertion to check whether it works correctly. Is the result really the sum of those two numbers? If it works correctly, great. What we get from this is also automated tests that can be automated, and you get regression testing. What we don't get is that we might be missing edge cases, and often we lose a communication with the client or the business. So, test-driven development. It's not a new idea, but it was a new idea for me several years ago when I was working at this large company. And one day a new QA came, and he was into all this gherkin, cucumber nonsense, and he said to me, hey, why don't we write the test first? So I said, what do you mean? I don't understand. That doesn't make any sense. I haven't written any code yet. Okay, so he explained to me, well, you know what the code is meant to do, right? So let's write some kind of assertion, some kind of expectation, and then check the code against that to see if it works correctly. And we did that for a few cases, and I thought, oh, that looks interesting. But it didn't really sink in, because at that point, neither the language nor the tools had evolved far enough for me or many other people to understand what this was all about. So let's roll back some of the history of what's called TDD. The father of TDD is usually acknowledged as Kent Beck, even though the idea existed long before. So he was said to have rediscovered TDD in 1994. And between then and 2002, he developed his idea and formalized what TDD was about. He's the guy that came up with the red-green refactor loop, the formalized steps that you go through with test-driven development, the idea that you can fulfill expectations or small tests that you come across them, baby steps, write a little assertion, write something that makes that pass, and so on. But just to show you how far back this idea actually goes, a guy called Daniel McCracken, 1957, in digital computer programming, wrote this. Now, it's a bit long. I'm just going to read the part in bold. Largely because logical errors and misunderstandings between the programmer and customer may be pointed out by such procedure. Because computations took so long, it was worthwhile talking with the customer about what the expectations were and to set up the expectations in advance so that you'd be able to know very quickly whether what you were doing worked or not. This also connects back to the idea of behavior-driven development, right? Because it's about ironing out the misunderstandings and miscommunications between the developer, the business, and the customer. So Kent Beck is most well known for this loop, the fail, pass, refactor. You write a failing assertion saying, this is what I expect to happen. Then you write a little bit of code, just enough code to make it pass, and then you do some refactoring, and then you go back to the failing example. And this was developed to a much higher level by guys called Steve Freeman and Nat Price in a book called Growing Object-Oriented Software, Guided by Tests. I'll mention that later. So Kent Beck, by the time 2002 came, he had written this book called test-driven development by example, where he takes people through specific examples of how test-driven development works. And one of the things he wrote was that it was a way of managing fear during programming, right? Because when we have very long, complex classes, we start developing this fear of adding new features and breaking the old features, breaking features in the existing application, and so on. And his idea was that his methodology would slow you down, and you would use it a little bit like a ratchet to slowly help you pull up a heavy load while there was some sort of safety mechanism that prevented you from sliding all the way back, because there were these regression tests that you could execute every time you changed something. Okay? This wasn't enough to push test-driven development into the mainstream. A quick sidetrack. We've talked about test, but there's also the word driven, which is often misunderstood. And that goes for all the DDs, BDD, TDD, DDD. And it's a critical word in the process, what driven means in the context of developing software. Right? So the developer goes, driven, oh, like in a car. Well, not quite. The idea is that you can drive software through various requirements or various constraints. When we start developing software, it's usually driven by fun. Then we get older and we realize we need to make money. It might be driven by profit. Then we start working for large companies, and we come across things called business requirements. And these business requirements can really drive the development of software one-to-one by extracting examples from the business requirements. Now, the word examples is something you come across a lot in BDD, and it's no wonder that the process that I'm talking about is often referred to as spec BDD. Because in BDD, you often ask the client for examples of how the software works, and the idea is that you can use those examples to then map out your software or fulfill each criteria, each example. There's an example where this happens, an example where that happens, an example where it doesn't work, and you gradually fulfill each of those criteria by following the examples, and you let the examples drive you, okay? So the test is problematic, right? We'll get rid of that. Development, we all know what that is. So we get development that is driven by something, and it's driven by examples, with the operative word here being driven. Development driven by examples. From here, we skip ahead to 2004. Specification by example, which is essentially TDD, but repackaged. Right? So we said TDD is dead, but this is the new way of looking at TDD, which allows us a new mindset, a new way of looking at things. And this was coined by Martin Fowler in 2004 in an article, which he wrote because he was frustrated about the uptake of TDD and the direction TDD was going, and keeping the abstractions grounded and relative to what the client needs, because often the developers were developing completely independent of what the actual examples of the software were, right? And he said that tests based on shared examples, The emphasis here is on shared examples. BDD is all about communication, remember? So developers and POs and clients share these examples. Best fit category of test designed to support a team while delivering software from a business perspective, ensuring the right product is built. Funnily enough, this goes back to what McCracken wrote in 1957, which just goes to show how long this idea has been kicking around, and what was missing from TDD, which is basically the communication. So now that we've understood that there's a misunderstanding with the word test because it can be both a noun and a verb, let's look at the word specification. Detailed description or assessment of requirements of a proposed building. It's a noun. It's unambiguous. It can only mean one thing. And in technology, it's often referred to as a spec, defined as a document describing how some system should work. Now, that makes a whole lot more sense, cognitively speaking, to say to a developer, can you write a spec first, rather than can you write a test first, right? So what's this? Is this a test? Is it a spec? Well, it depends, because you could have written the function first and then written this and executed it, and that would be a test. Or you could have written this expectation beforehand, and that would be a spec. So you see how exactly the same code can be both a test and a spec, depending on the context, depending on whether you're executing it or writing it, whether you're doing it beforehand or afterwards. Which reminds me a little bit of this picture, the famous duck rabbit. Right? Is it a test or a spec? So here's a handy little flowchart. Did you write the code before? Yes, then it's a spec. No, then it's a test. Also, the act of running the specification is a test. So you can see how confusion abounds. A little digression into psychology and linguistics. In the 70s, psychologists came up with the idea of reframing, changing the language, changing the way of thinking about the same problem by changing the language used to describe it, right? And this is really what we needed in TDD. And to quote from that book, to reframe means to change the conceptual and emotional setting or viewpoint in relation to a situation which is experienced, to place it in another frame which fits the facts of the same situation equally well or better, thereby changing its entire meaning. Now, this use fits very well with the way we replace the word test with specification, because it fits the facts of the same concrete situation of writing a test before the code even better. And it does change its entire meaning, because when you think of writing a specification, you're in a completely different mindset than when you think you're writing a test. So the revolution started to happen here. This is a change in language. RSpec, 2005. Notice they call it Making TDD Productive and Fun, which will give you an idea of how boring and horrible it was before, with the emphasis on the word fun, hopefully. And several years after that, they came out with a book called the RSpec book. It's worth reading the first few pages, where they said, don't rush ahead with code. Instead, add another example and let it guide you to what you have to do next. So, in other words, slow down, don't rush ahead. Project managers don't like this very much. And use the examples to guide you. Don't hurry. Slight digression. Around 2010, this idea evolved a whole lot more, and I encourage you to read just the first 2 chapters in this book, because the rest of it is Java examples, and it's not very interesting. But they use tests to drive the features, and they talk about using mock objects to discover and describe relationships between objects, which is a kind of preamble to what we're going to be doing in a minute. So following RSpec, a guy called Pradik Brady and Travis Weisgerd wrote PHP spec in 2007. It was basically a port of RSpec, and it called itself Spec BDD. Later on in 2010, we have PHP spec 2, which is, as we know it now, a complete rewrite of PHP spec by Marcelo Duarte and Konstantin Kudryashov. Now, it's enlightening to look at what Pradik Brady had in mind. PHP spec implements a DSL for PHP for specifying behavior. Right? The purpose of the DSL was to move away from XUnit style declaration towards a specification language centered on describing behavior. Right? So describing here is the operative word. Instead of writing a test case, or instead of writing a test class, you describe a class. And this fits in a lot better with the idea of writing a specification. So here we come to PHP spec. Tool set to drive emergent design by specification. Marcelo Constantine rewrote it. It's now maintained by Kieran McNulty. And you see you've got all the right keywords here. Tool set to drive emergent design by specification. And the way it's used is a bit like this. Just quickly about the difference between how you do it in PHP unit and PHP spec. PHP unit, you write what the test is about, and then you make an assertion. And in PHP spec, you write a description, and this refers to the object that you're testing, and you're saying the method should return, and you set up expectation of behavior. So I'm just going to quickly go through an example of how you'd use it. The most trivial example is called string calculator, where you have the following examples. It returns 0 if an empty string, bare number given 1 number, returns a sum of numbers separated by space. So you start off by describing your object, describe calculator. It offers to create it for you, and then it passes because the class has been created. It gives you an example specification. That's the class. And then you write your first example, return 0, and you say this add empty string should return 0. And then it politely offers to add the add method to calculator. So you see it takes you by the hand, step by step through the TDD process, which was very important for people who are newcomers to TDD. You return 0 just to make the test pass. Then you write another case, returns the bare number, should return 2. It doesn't return 2 because you get 0. Then you fix it so it returns the number. It doesn't return the number, returns a string. Then you cast it to an integer, and it passes. And so on for the third example. It needs to add 2 numbers together. It fails, so you do some computation that sums up the number in the string together, and that passes. So very, very small steps. It takes you by the hand. It helps you in every step of the way. So you can see it's not just a design turn, but a learning tool, right? So a real-life example. I was told it would be useful to show how this can be used in a real project or even in Laravel. You've got a product owner who says, I want something that will allow searching Wikipedia for a keyword, keep track of past searches, highlights results, but not the current one, because that would just fill up the page with highlighted results. And of course, the developer goes, oh, right, well, I guess I'll need to store all the searches in a database, or maybe in a session. He starts thinking about how these remote calls are made, and what the Wikipedia API is like, and what the highlighting color is. And these are all distractions. Instead, we should be focusing on one problem. Ignore the infrastructure around, ignore the framework for now, and look at what's left, which is basically one or two classes for this example, which are your core domain where the business logic is contained. So that means I need to talk a little bit about what this infrastructure boundary means. So there's this idea called hexagonal architecture, with your domain or business logic in the middle. These are pure classes that can work anywhere, regardless of the framework, and you've got some thing that connects to a storage, a framework, or a remote API, or a framework controller UI. And in the case of Laravel, that might be Laravel model for storage and the query builder and a Wikipedia search. And you would have a Laravel controller to give you the input from the user and Blade to render the template. Okay? But these have nothing to do with the core domain of your application. So let's put all that in background and see what will represent each of those infrastructure boundaries. We'll have a client, which can search for things. We'll have a search history, which can track, which will just store something in a database, find all search history, which will get all the history. A search controller, which will have a lookup action. And in the middle, we have our highlighting search, which is our core domain, which is what we're going to develop right now as search. And we have a search result. Search result object is something that can be highlighted, and it can also match against history. So to simplify highlighting search, I delegated some of the functionality to the search result. Right? And there are relationships between these. This is a UML diagram. And you see here that highlighting search uses as dependencies a client and a search history, and it aggregates search results. Okay? In PHP spec parlance, all the stuff around the hexagon are called collaborators. These are our collaborators. This is our main class that we're developing. But there's also a search result. We don't have time to develop the search result, so that's going to be an interface too. These are all known as doubles or mocks. I don't have time to go into what these mean, but basically they are stand-ins. They stand in for the real thing so that you can focus on just developing the business logic in the highlighting search, right? So these are all out of the way. Nevertheless, you still have the same relationships. It still has these dependencies. So when you create a spec for this highlighting search, you say that it's constructed with these two dependencies, which are set up as doubles. And in the actual constructor, you can see that they're set up with these doubles as dependencies, right? These are our periphery. The interfaces just look something like this. Search history, client can search for, and search result can highlight and can match. Okay? So this is our shopping list that we've kind of derived from the PO. Keeps track of search history, does all these things, right? Ignores current search term, only matches whole words. Some of these are delegated to the search result because there's no time to go through all of them. Also, for the search result to match against historic terms is something that's done by the search result. But the logic of does or doesn't match is taken care of by the highlighting search. This one is not necessarily a requirement. This is not the kind of thing that a PO or a client would give you because they don't care whether there is or isn't any search history. So we might skip that. Okay? This is what the controller would look like to start with. It just takes a search term and has an empty array for the results, and this is where we would like to plug in our highlighting search. The Blade template looks something like this, takes an array of results. If the result is highlighted, it prints a title. If it's not, it doesn't highlight it, and it always prints a snippet, which is also something you get from the Wikipedia search. And then when there's nothing plugged in, you just get this. Okay? So we start building the highlighting search. So we start by describing the highlighting search class. We get PHP spec to create that for us. It's created an example spec. And when we run that, it's going to offer to create the class for us, right? That's the first step, very, very basic. And we can see that it's created the highlighting search class, okay? Next step is, remember we have these collaborators, the search result, search history, and the client. Okay, I'm just going to namespace them now because it's going to make it easier for PHP spec to create them for me, right? I don't have these things yet, but PHP spec is going to implicitly create these doubles for me. Remember? These things that stand in for the search history, and for the client, and for the search result. And remember, we need to construct the highlighting search with the two dependencies. It needs the search history, and it needs the client. Okay? Then we go back to run it, and it's creating these interfaces that don't exist yet. And it's also created a constructor for us. So now we can see that it's created a client interface, search history interface, a constructor, and a search result interface to start with. And in the constructor, we need to set it up, of course, so that our dependencies are injected. We've got the search history and the client. Remember, for the moment, these are coming from the spec. So they are doubles. They may be mock objects or dummy objects. The next step is to actually follow one of the examples. It tracks search history. Okay, what does it mean to track search history? It's not the highlighting search that tracks. It delegates the tracking work to the search history, one of its collaborators. So what I'm saying is that when you search for the keyword Laravel, then I'm going to expect that the search history with a method track will be called with exactly that keyword. So search history track should be called. Remember, track doesn't exist yet, okay? So it's going to offer to create the track signature on the interface and also the empty search method. And it says that it expected track to be called right there, and it wasn't called. So what we need to do is go to the highlighting search, where you can see we have an empty search method created by PHP spec, and all we need to do is say search history track whatever term we're given in. And remember, track is going to be implemented as a very, very simple database function. See, this passes, and all good. So go to the next case. So it returns an array of search results. Okay? What are these search results? Well, we've got a double of a search result set up. Remember, it's a stand-in. It's not a real search result. It's just something that will help us develop this highlighting search in isolation without anything else having to exist. Okay? So we don't know what it's going to return yet, but remember we've got a client, and I want this client to have a method called search for. And I want to say that when I search for Laravel, notice a spelling mistake here, it will return some search result, an array of search results, which are exactly this collaborator that we specified here. Search result up there, search result down here are the same object. So when I search, I want it to return exactly the same search results. It's going to offer to create the client search for interface. It says it's return null because the function doesn't yet return anything. All we need to do to fulfill this obligation is to return whatever client search for returns. And remember, it has to search for exactly that term, because we said only if you search for Laravel, you will get these things. Now, something was not expected, and that's because we've misspelled Laravel. We'll just fix that to Laravel, run the test again, and there we go. We've got 2 examples passing, right? So now we go to the next one, which is dealing already with highlighting searches that match results. And we're not going to talk about how the results are actually matched at this point. What we're concerned with at the moment is that the search result is highlighted. Remember, the search result has a highlight method. So what we want to do is make sure that the highlight method on the search result gets called. Now, it doesn't have the actual highlight method in the interface yet. I just talked about it in the UML diagram. So this is going to also force PHP spec to create this method signature in the interface. We say highlight should be called when I search for Laravel. In fact, it doesn't matter what I search for. I just want to make sure at the moment that highlight is called, and this is going to drive me to, okay, see, it's offering to generate the method signature. It's saying that it's expecting highlight to be called, but it wasn't called, right? And in order to fix that, we go to the highlighting search, and we do the minimum to make this happen. We're just going to put the results from the search into a results parameter and say highlight on the first result. And this should allow our test to pass, right? Let me go and run the spec again. It passes, and you can see now we've got 3 examples working. We go to the next one, which, remember, wasn't a strict requirement from the PO, but probably something that the developer put in, maybe part of a premature optimization. They just want to know that the highlight search results, when history is empty, doesn't go through all the processing and matching. So it makes sense if the history is empty just to return the results as they are. So in this case, highlight shouldn't be called. Now we have to set up what search history does. We're going to say that it's going to have a method called findAll, and when that method is called, it's going to return an array of my search history. This is just an arbitrary list of keywords which I imagine to be in my search history. It's going to generate the signature for findAll, and then it finds a problem because track was not expected in several of the other examples. See, track is used, but it's only important that it should be called when it tracks search history. For the rest, all we need to know is that it returns and it exists. Okay, so we're back on track with highlight, expecting highlight to be called, and it is called. So what does it mean for the search history to be empty? It means that when we call findAll, we'll return an empty array, right? This will still fail, as there's no logic. It says it wasn't expecting highlight to be called, but it's still called highlight. We don't want it to call highlight when the history is empty. So what we do is now we've got the historic terms, which were set up by the specification. The historic terms are search history findAll. And all we need to do is check if they're empty. So if historic terms are empty, then we want to return the results as they are and not go through the rest of the processing. We don't want to highlight anything. We don't want to match anything. We run, that passes. Now we've got 4 examples passing. Okay? Now we do just a little bit of tidy up on these interfaces so that they are more PHP 7-like. Track is a string with a term, and find all returns an array. And search result highlight, that doesn't need any modification. So back to the specification. Now, it does not highlight search results that don't match. And here we're going to have to deal with what matching actually means. Okay? We don't have the match method on the search result. So we're going to have to deal with that. First of all, okay, so we need the search result collaborator here, which is the same search result object exactly. It matches them by name. We can copy-paste highlight should not be called, because also in this case, we don't want highlight to be called. But we don't want highlight to be called if the search result doesn't match our historic terms. So we're going to say, I'd like a method on my search result called matches, and when that method is called with exactly these historic terms, I will return Boolean false, and I will expect this to pass, because when matches returns false, it should not be called. So now it's going to generate the matches signature, but it says one call was made to highlight, so that's not good. We need to deal with this case. So we go to the implementation, hopefully, and what we do is we check whether results 0 matches our historic terms, which we know what they are. We get them from the spec. And we only want to highlight if they match. And if they don't match, we don't highlight. Okay, so we'll go run the spec. Say, there's another case here that relies on matches. Remember, it highlights search results. It highlights search results that match historic terms. That's the case where they do match. So in this case, what we need to do is simply copy this matches line and say for the case where it does match historic terms, it will return true. And we get passing examples again, right? That's almost all of our requirements. One more to go here. First, we're going to do a little bit of refactoring. We know that results is an array. We want to process all of them in exactly the same way, so we can safely do this. I know there's nothing explicit driving it, but you can think of for each as a basic language construct. You know what it does. You don't need to test what for each does. We just need to make sure that all the examples still run correctly. Okay? So now we go back to the spec and we write the last case, which is where it needs to ignore the current search term. So it ignores the current search term. What does that mean? The current search term in all these cases is Laravel. And we need to search for Laravel as we do before. But the difference is that the matches, we will expect it to be called we expect Laravel to have been removed. It's supposed to ignore the current search term, so we don't want it to be matching on this current search term. We expect it to be removed before we process it. So we just expect matches to be called on the second word, which is framework. So we say search result matches framework should be called exactly that. And of course that will fail because you can see it's expecting Laravel and framework, but it matched exactly framework. So we go into the implementation, and we write a very quick method to remove the current search term just by writing array values, array diff. This is the quickest way. If you had a collection, you could do a Laravel collection, you could do reject. That would be enough. Now that's removed the current search term, but we see that some of the examples failed because they are also expecting to match on both the search terms. So we're going to change those to say they should only match framework, and we get it to pass. Okay? That's basically it. We do some little bit of refactoring here. We can make this into a private method and tidy up the code a bit. Remember, there's a refactoring stage. And if there's 2 minutes left, I'd just like to show you it working with Laravel. Okay, so we built this, highlighting search. We're going to plug it into that controller that you saw earlier, and it's going to work. Okay, the search results has already been created. So I am going to switch to the editor. And here, I'm going to say, I want highlighting search. Okay, let's say, first of all, before you have this in, you just get that, right? After you have it in, we get this. And you can also see that the search terms are being tracked, right? Now we can see there's a term in one of these called software. Let's search for software. There's nothing actually highlighted here, but if we go back to Laravel and reload it, we'll see that our historic search term software is highlighted. If we go to programming, nothing highlighted here because it doesn't have any of our search history, but we go back to Laravel, and we see that the entry with programming is highlighted correctly. And it's also tracked all our search terms. Now, if you want to see what the actual implementations look like, we've got a very, very simple web client which implements the client interface. It just makes a query. There's no business logic, and returns some search results. We have a wiki search result which implements search result. It's also fairly simple, but it does have a complex function here which has matches in order to match the search history, right? And for that reason, it has its own specification, right? What it does when it matches, when it doesn't match. And inside the Laravel app, we've got an implementation of search history, which is also very simple. To track, it just stores something in the database. To find all, it just gets all and returns an array. And we've got the app service provider that maps the interfaces to the concrete classes that we're using. And that's it.